Welcome and a good day to all our viewers. My name is Iskandar, and today me and my lab partners are going to present the findings for our experiment, which is Sedimentation Studies Apparatus. First of all, what is sedimentation? Sedimentation means the separation of suspended particles that are heavier than water. It is widely used in the industry, but mainly it is used for wastewater treatment system. In our experiment, we divided into two parts. The first one is part A, which we put different concentrations and initial heights in 5 different glass cylinders. And what we are trying to find is the rate of settling using different initial height and concentration. For part B, we use the same procedure as part A, but this time we add flocculants. Flocculants, we use aluminum oxide and we put it into the composition. So, what are the causes of sedimentation? It is caused by the motion through the fluid in response to the force acting on them. These forces include gravity, centrifugal acceleration, and electromagnetism. The differences between settling and sedimentation are settling is the falling of suspended particles, while sedimentation is the termination of the process of settling. So, what are the factors that affect the rate of settling? The major ones include particle size, density, concentration, and fluid viscosity, and also height of the water container. Besides the huge factors, there are less obvious factors, including particle shape and orientation, convection currents, and the chemical pretreatment of the feed. So, in the theory part, what we hope to find in our experiment, so as you can see in figure 1A, the total depth of the suspension is Z0, and a zone clear liquid, which is zone A, as you can see in part 1B, and zone D of settled solids can be seen. In zone B, the concentration is uniform and equal, since the settlement is the same throughout the zone. The depth of zone C remains nearly constant, and that of zone B decreases. The gradual accumulation of solid puts stress on the material at the bottom, which compresses solids in layer D, as can be seen in figure 1E. So, for the graph, this is the graph of liquid interference height against settling time. So, as you can see in the first portion of the curve, it shows that the settling velocity is constant in the early stages of settling, and then the rate of settling starts to decrease when zone B starts to disappear, and steadily from that point it drops until it reaches a point where the process becomes very slow. And when it becomes very slow, this is where the final height is determined. So for the next process, which is methodology, I will pass it on to my friend Faiz to continue with this presentation.
Okay, for methodology in experiment, we use 3 important apparatus, which is stopwatch, beaker, and cylinder. We use 5 equal size of glass cylinder, 53 mm outer diameter, with length 1000 mm and thickness 2 mm. Beaker is used to prepare the initial solution for the experiment, and stopwatch we use to record time taken for experiment. For procedure, there are 2 parts of experiment. First part is study the effect of different initial height and concentration on the settling rate without using the propellant. First, make sure all the cylinder is empty, and then prepare with respective. Prepare a solution with first concentration 25 gram of kaolin in 1 liter of water at height 90 cm. Second, concentration of 50 gram of kaolin in 1 liter of water at height 90 cm. Third, concentration of 25 gram of kaolin in 1 liter of water at height 60 cm. Fourth, 50 gram of kaolin in 1 liter of water at height 60 cm. And fifth, 50 gram of kaolin in 1 liter of water at height 30 cm. Then we record the initial time, and for each 5 minutes, for 30 minutes, we record the height for each cylinder, and then the final time and height is recorded. And for the graphing, we plot height of clear liquid interface Z against the turning time. For second part, the procedure is still the same. We just add flocculant for each cylinder. For the first cylinder, we add 5 ml of aluminum oxide. For the second one, 10 ml of aluminum oxide. The third one is 50 mm aluminum oxide. The first one is 20 mm of aluminum oxide, and the fifth one is 25 mm of aluminum oxide. And all the steps is the same like the initial one.
On the raw data that we obtained, we actually plotted 5 graphs, which is the height versus time for each cylinder, which is A, B, C, D, and E. So this is the first graph. This is the graph of Z versus time for cylinder A. This is the graph of Z versus time for cylinder B. This is the graph of Z, which is the height versus time for cylinder C. This is the graph of Z versus time versus for cylinder D. And this is the graph of Z versus time for cylinder E. So as you can observe in these 5 graphs, each of them has a similar pattern, and the settling rate increases against time. The blue line actually represent the one without flocculants, and the green one actually represents the one with flocculants. So the one that we added with flocculants, which is experiment B, the difference in height is actually much greater compared to the one that we never add the flocculants. So why is this so? Because we can conclude that flocculant is actually an coagulant agent, which helps the flush to settle much more faster.
So we move to the next part, which is discussion. So as my lab mate told earlier, we got 2 parts, which is part A and part B. So in part A, we want to discuss and study about the rate of settling of kaolin powder and the different height and concentration. So based on the result obtained earlier, we know that higher concentration use time taken for the slurry to settle to the bottom higher. So this means the settling rate decrease. The next one is the initial height. So as the initial height increase, the time taken for the slurry to settle to the bottom also increase. This means the settling rate decrease. So we can conclude that if we increase the initial height and the concentration, the time taken for the slurry to settle at the bottom also increase, thus the settling rate decrease. So we move to the second part, which is part B. So we know that in part B, we want to study the effect of different volume of flocculant on the settling rate. The second part, we use the same method as the first part, but the only difference is we add the flocculant to the cylinder, and then we can see that when we add the flocculant, the the time taken for the slurry to settle to the bottom decrease. So we can conclude that with flocculant we can increase the settling rate. So why this happens? Because this flocculant actually coagulate all the slurry inside the solution to make them coagulate together and make it settle to the bottom faster. So next. So in our experiment, they got actually we got 3 error, which is instrument error, parallax error, and next is human error. In instrument error, this is maybe due to the weighing machine that we take the volume of choline and flocculant. Second one is parallel error. Maybe this is when we take the reading of the height of the cylinder. Maybe we got some parallel error there. And third one is human error. Human error comes for careless, poor technique or bias of the human. Next. So how we want to overcome this error so that we can get a more accurate result. So first, we can fill the column, contaminate its cause and accurate reading. Thus, after every experiment, solid must be need to remove by washing the column. Next, we need to check the equipment first before starting the experiment and make sure there is no leakage of the system. So, in order to increase the accuracy, we need to make sure our eye is parallel to the level of the cylinder. And next, we as a lab net, we need to focus during the experiment and be more focused to avoid any human error. So I pass to my friend for the next part.
Okay, in conclusion, we can know that sedimentation process is the process of separation of the slurry solution to the clear fluid and the solid particles through gravity settling. And the objective of this experiment is achieved. For experiment A, we can conclude that the initial height and the concentration of the solid particles solution will affect the settling rate. As the height increase, the settling rate will decrease. Since go to the concentration, as the concentration increase, the settling rate will decrease. Okay, for experiment B, we can conclude that as the volume of flocculants increase, the rate of the settling will increase. This because the flocculant act as the helping agent that to aid the process of the sedimentation to occur faster. Next. Okay, this is the reference that you refer to when doing the whole report. Next. And okay, here this is the cylinder that we use to observe the sedimentation during the experiment. And this is the choline that we use to mix with water to produce the slurry solution when during the experiment. And the aluminum oxide is the flocculant that we use as the aid agent in helping the sedimentation to occur faster. Okay, that's all for my presentation.